Okay, now in this packet, the first part's really easy. You're just solving for what this is. Okay, finding what it's equal to. So -5, that means -5 times -5. Now there's two negatives. That's an even number. So an amount of two even, if you have two negative factors, an even amount of them, probably going to be positive. So the product is 25. Okay, next one, -7 to the third. Find what that equals. So -7, clone -7 3 times. Okay, -343. Okay, if it's a fraction, that's fine. You can easily find what that equals if you just clone the fraction. Then you multiply the top, the numerators, and the denominators. So 2 times 2 times 2 is 8. And 3 times 3 times 3 is 27. 8 over 27. Okay, last problem. 8 times 8, and that equals 64. Okay, then on the back side you got some expressions with variables to simplify. So I make sure first in the expression I create a line because there's a possibility things might move to the other side, and then I circle, bubble up the parentheses, just the parentheses. So we have a 3 out there, so anything from this parentheses, any exponent from here has to be multiplied by 3. Not the 2 doesn't though. Okay, so I have a number 4 and a letter X. Okay, so 4 is to the 1 power, but it's in the bubble, in the parentheses, so I got to multiply 1 times 3, and that's 3. So 4 to the 3rd power. Okay, now X, there's two X variables. Here's the first X variable. It's to the second, so I got to multiply 2 by 3, and that's 6. Now the other X, is it on top or bottom? It's on top, so you're going to plus, and then it's just 2. You write 2 down. So 6 plus 2 is 8. Okay, now here are your two factors. They're both positive, so they're both going to stay where they're at. So stay, stay. So that stays on the top. And that stays on the top. Okay, then I clone what I can. Okay, 4 to the 3rd. You can clone the number 4 3 times. And then you multiply the 4's together. So 4 times 4 times 4 is 64. So replace this with 64. Then x to the 8th power. And that's your answer. 64 times x to the 8th simplified. Okay, my next problem, again, make your dividing line. Now circle your parentheses, and then we got a -2 outside of it. So pretty much every exponent I see has to be multiplied by -2. There's nothing outside the bubble. So I have a number 4, a letter X, and a letter Y. Okay, so 4 would be to the 1 power. If you don't see a power there, you put a 1 there, but it's in the bubble, so we got to multiply 1 times -2. That's -2. Okay, then the X factor, it's 2 times -2, it's in the bubble. So 2 times -2 is -4. And the Y factor, 3 times -2 would be -6. Okay, now here's all my factors. They're all negative this time, so they all go to the opposite. OPP stands for opposite. So 4's on top, so the opposite of the top would be the bottom, and then the -2 turns positive. X is on top, so that goes to the bottom, and the -4 becomes a +4. The Y is on top, so the opposite of the top's the bottom, and -6 becomes a 6. Now, we never want the top to be empty, to have nothing in it, so you put a 1 there. Okay, so we carry the 1 over, and then my 4 factors, the only one I can clone is the 4. So 4 times 4 is 16. So replace 4 to the second with 16. times x to the 4th times y to the 6th. Okay, now you got two different dividing lines, so you just connect them. And then look at where you got parentheses. You have this one with a 2 outside, so any power out of here has to be multiplied by 2 before I write it down here. Okay, and then I have this parentheses here with a 3 outside, so any power from here has to be multiplied by 3. Okay, so on top of my line I have a number 8, a number 6, and a letter x. So 8 times 6 times x. Now under the line you have a letter x, which you already wrote on top. So since I have it on top, I don't write it again. And then I have a y variable, but I don't have that on top, so I actually have to write y on the bottom. Okay, so now let's figure out some exponents. So 8 is to the 1, but it's in the bubble, so 1 times 2 is 2. 6 would be to the 1, but that's in another bubble with a 3 outside, so 1 times 3 is 3. And then x, now there's two x's. Here's the first one to the third, but again, you got to multiply any power here by 3. 3 times 3 is 9. Then you have another x, and where's that at? Is it on top or bottom? It's on bottom, so I will subtract. Now you got to remember, you see a 3 there, but that's in the bubble, okay? So you can't write 3 down. You have to multiply 3 by 2. And 3 times 2 is 6. So 9 minus 6 is 3. X to the third. Okay, then y. Okay, now you got to remember, y is here, but it's still included in the parentheses. It's still in the bubble. So I can't write 2 down. I have to multiply 2 times 3. And that's 6. So here's my factors. They're all positive, so they all stay. Okay, so 8's on top, it stays on the top. You want the 2 to stay positive. The 6 is on top, stays on top. The x is on top, it stays on top. And then the y's on bottom, and it's going to stay on the bottom. Okay, now we have these factors. Now which ones can we actually clone? We can clone 8. 8 times 8 equals 64. So we replace that with 64. 6 to the third, you can clone 6. 6 times 6 times 6. It's 216. Okay, so that equals 216. So 6 to the third is replaced with 216. And then the x can't be cloned, so it stays x to the third. And the y can't be cloned, so it stays y to the sixth. Now, you actually have to do an operation with these two big guys here, the 64 and the 216, because they're on the same side of the line, and it says you're multiplying. So I take 64 times 216, and I get 13,824. So I replace that with 13,824. Okay, now this one was giving some people some problems last Friday. Your dividing lines here. Now the parentheses only surrounds the 4 and the a with the -2. So you just circle the 4 and the a. So any exponent coming from the 4 and the a has to be multiplied by -2. This, and this are just jotted down because they're not in the bubble. So on top of the line I got 4, a, and b. And on bottom I have a letter B, which I already have on top, and then an A. I've already written A down. Okay, so 4 is to the 1, and that's inside of our circle, inside of our parentheses bubble. So 1 times -2 is -2. Okay, now A factors. Okay, here's the first A. It's to the 1, but that's in the circle, so 1 has to be multiplied by -2, and that's -2. Okay, now, where's your other A at, top or bottom? It's on bottom, so you're going to write a minus, and you got -3 as its exponent. Now, that is not in the parentheses. I did not circle that, so I actually write -3 down. So parentheses -3. Again, anytime I have minus and then I get a negative, I want to write a parentheses. So -2 minus -3, and I get 1. So it's a to the first power. Okay, now B, I have an 8. It's not in the bubble, so I don't multiply 8 by anything. I just write 8 down. Okay, and then where's your other B at? It's on bottom, so you subtract 3. 8 minus 3 is 5. Okay, so my three factors are 4, A, and B. So that's negative. That goes to the opposite. And that's positive, so that stays. And that's positive, so that stays. So the 4 is opposite, so it's on top now. So the opposite of the top's the bottom, and the -2 goes to a 2. Okay, the A's on top, and it stays on the top with its first power, and the B's on top, and it stays on the top with its fifth power. Okay, so the only one of these I can clone is 4, so 4 times 4 is 16. So we just put a 16 word that in for that 4 to the second, and then these variables really can't do anything with. A to the 1 times B to the 5th. Okay, scientific notation, taking a number, writing in scientific notation. So your opening decimal's right there, okay? You can see it very well. That's me making it more obvious. All right, now find your first non-zero digit. Right there, 8. So the decimal goes between 8 and 9. Got to go here. To get there, we got to move this way. So that's moving to the right. So our exponent is going to be negative then when we go to the right. It's the opposite of a number line, okay? All right, now move your decimal where it belongs. 1, 2, 3, 4, 5, 6, 7. Okay, I should have done this first. Blank times 10. It's going to be a negative power. So the decimal's here with an 8 in front and a 9 behind it. So 8.9 times 10 to the negative 1, 2, 3, 4, 5, 6, 7 to the negative 7th power. Okay, and you can always check it on your calculator. 8.9 times 10 power negative 7. And that looks like exactly what I started with. Okay, taking a number and writing it from scientific to standard is easy. You just take 3.8 times 10 power 7 on your calculator. So 380,000,000, and the decimal's here, so you don't need to write it when it's at the end like that. And 38 million is that actual number. Okay, now a couple story problems. Gas prices are originally $3.29. They will decrease by an average rate of, remember, decrease means minus, okay? By an average rate of 2% per month. Find that gas price 6 months later. So I have two units here. You got the dollars and the months. Okay, so the months would be my X variable because that's your time, that's your independent variable, and Y is the money, that's your dependent variable. So per month, and that'd be dollars per month. Okay, dollars per month, all I see about per month is 2%, so it's a percentage, okay? So you want to know how many months you have. When you have a percent, you want to know how many months you have. So 6, okay? So blank times blank equals blank. Now since it happens per month, we need an exponent here. And then we use our new percent, or sorry, original, times percent equals new. All right, so I do my percent first. I take 100%, and decrease means minus 2, and that's going to be 98%. Now that has to be divided by 100. That gives me 0.98. Okay, and then the original amount's $3.29 Now, I have to put a power here because it's per month, and we have 6 months. So it's to the 6th power, and then x. Okay, so I got 3.29 times 0.98 to the power of 6. Okay, so we're talking a money amount here. So if it's dollars, you want the first 2 digits after the decimal point. So $2.91. Okay, and then finally in this one, the number of students enrolled in the school district is 2,500 students. That's the original amount. The amount increases, increase means add, increases by an average of 5% per year. How many students will be in the school 5 years from now? So again, we have 2 units. We're dealing with students and years. Okay, years is X, students is Y. So per year, students per year. The only thing I see about the per year is the 5%. Okay, so I know I'm not going to make a line when it's by a percent. Okay, figure out how many years you have. Well, you got 5 years. So we're going to use the changing percents equation. So we have our original. We're going to need a power again because it's per year. Power is going to be 5, by the way. And then new. Okay, do your percent first. So you got 100%. And then increasing is adding 5%, and that's 105%. So you divide that by 100. 1.05 is the percent. All right, then 2,500 is the original, and then x. So I can just multiply. I don't need to divide. So 2,500 times 1.05 to the power of 5. 3,190. Now, since it's students, that says students here, you don't want anything after the decimal. So 3,190. You could also put 3,191 if you wanted to. It's between the two amounts. It's just an approximation. Okay, now in the polynomials standard, you just perform operations. So in the first parentheses, you have a plus sign. So right away with a plus sign, I look for my highest x power to the second. So blank x second plus blank x plus blank. So x second, I have a 2. And this would be a 1, okay? So I add those. 2 plus 1 is 3. Don't need a calculator for that. Okay, now x, you got negative 5x and negative 1x. So you take negative 5 plus negative 1, negative 6. Okay, then your constants, you have a positive 1 plus a negative 4, negative 3. Okay, and that's your simplified polynomial. There's your operation. All right, now you have a minus sign, so it's the same thing. Your highest x power, 4, 3, and then 4, 2, and 1. Okay, so 4 is the highest of the group. Then you run it down. Okay, so x fourth, I have 5x to the fourth. And negative 2x to the fourth, but remember you're subtracting. So I take 5 minus negative 2. Now when I subtract the negative 2, it's really just the same as the simple operation of 5 plus 2, which is 7. Okay, then we can cancel those. Okay, x to the third, we have negative 2x to the third, and I don't have an x to the third in the second polynomial, so it's just really negative 2 minus 0, which would be negative 2. Okay, x to the second, well, you don't have anything here. You do have this 8 here. So how you do that operation is 0 minus 8. Negative 8. Because you don't have any. It's like you're taking it away from 0. Okay, x's. Don't have anything here. You have an x here, put a 1 in front, so it's like taking 0 minus negative 1. Same as 0 plus 1, which is 1. Okay, and then my constants, I have 9 and 2, so 9 minus 2. 7. Okay, and that's your answer. Okay, now the next one. Now you start multiplying, okay? Because when I don't have an operation sign between the number and parentheses, that's multiplication. So we need rainbows. 2 to 5, 2 to negative 1. So that's only 2 rainbows. This is a short one. So 2x to the third, 2x to the third. It has 2 rainbows. And I'm going to be multiplying that by 5x and then by negative 1. Okay, so your x's, that's a 3 and that's a 1. That's a 3 and that has nothing. So I take 2 times 5, that's 10. And on x, I'm going to take 3 plus 1, which is 4. 10x to the 4th. Then 2 times negative 1 is negative 2. And then for x, you just have a 3. Don't add anything to it because you don't have another x with a power. Okay, these powers are different, so I just write them over here as a plus. 10x to the 4th plus negative 2x to the 3rd. All right, now on the next page. Another multiplication operation, so we need rainbows. We want to put 1s here so I know exactly what I'm distributing. So 1 to 1 and 1 to negative 1. So you write 1x from here. There's that 1x down twice because you just drew 2 rainbows. And you're going to times it by 1x and then negative 1. Now repeat the process then with negative 8. So negative 8, negative 8. And I will be timesing by the exact same terms, 1x and negative 1. Okay, now before we find the products, we've got to put some powers on the variables. So 1, 1, 1 and nothing, nothing and 1, and then nothing, nothing. Okay, so 1 times 1 is 1. Then on x, it's 1 plus 1, which is 2. So 1x to the 2nd. 1 times negative 1 is negative 1. Then on the x, you just have the 1 power. Don't add to it. Negative 8 times 1 is negative 8x, and then to the 1 power. And then negative 8 times negative 1 is positive 8, and I don't have to worry about powers because there's no x's. Now, we got some powers that are the same. That's a 2, a 1, 1, and nothing. So these two are like terms. So we want to draw our blanks out here so we can organize our work. So the second power is the highest, then x, then that. So x second, we just have the positive 1. Then for x, that means we're looking for the first powers right here. Then you add. Negative 1 plus negative 8 is negative 9, okay? And then we have our constant term of 8. Okay, number 5 is a little bit longer. Okay, it's multiplication is the operation, so we need rainbows. So I circle 1x, and 1 times 2, that's a 1 there. 1 to negative 1, 1 to negative 7. So I write that down 3 times this time. And I times it by 2x to the 2nd. I times it by negative 1x. And then I times it by negative 7. Okay, and that's done. And now I distribute the positive 5. Okay, so 5, 5, 5. And I'm distributing it to the same 3 terms. So 2x to the 2nd, negative 1x, negative 7. 1, 2, 1, 1, 1, nothing, nothing, 2, nothing, 1, and then nothing. Okay, so I take 1 times 2, that's 2. And then on x, we're going to be taking 1 plus 2, which is 3. 2x to the 3rd. 1 times negative 1 is negative 1. Remember, times it. And x, you're going to take 1 plus 1, and that's 2. Negative 1x to the 2nd. 1 times negative 7 is negative 7. Then on x, you just got a 1. Then 5 times 2 is 10. Then for x, you just have a second power. 5 times -1 is -5. For x powers, you just got the 1. 5 times -7 is -35. So out of all those products, some of them got to have the same power. Yeah, you got 2x to the second power terms. And then you also have 2x to the first power terms. Okay? So my highest power is a 3. So when I'm organizing my work, it's blank x second plus blank x third plus blank x second plus blank x plus blank. So x to the third, we just have the 2 coefficient. For x to the second, we have a -1 and a 10, so I have to add those. -1 plus 10 is 9. Okay, for x's, you're looking at first powers, these two, -5, -7, -5, so I add those, and that's -12. Okay, and then in our constant space, we just have the -35. Okay, number 6, we have a binomial to the second power. Okay, remember, you don't see the 3 boxes there because that's not how you do this problem. Because with that plus sign, or if it was a minus sign, if I have a plus or minus operator within the expression with the power, you're going to need to duplicate it with a times and then by the identical parentheses. Okay, so then it's times, so I distribute 4 to 4 and 4 to 1. So 4x times 4x times 1. Okay, then I distribute the 1. Okay, so 1 times, and it'll be the same 2 factors that I multiply by. Okay, x's, you got 1 and 1, 1 and nothing, nothing and 1, and then nothing at all. So 4 times 4 is 16, and on x you take 1 plus 1, that's 16x to the second. 4 times 1 is 4, then on x that'd be to the first. Same thing on the next one. And then 1 times 1 is 1. So these two have identical powers, making them like terms. So blank x to the second plus blank x plus blank. So the x to the second power is 16. X, you're going to add these two together. 4 plus 4, which is 8. And then 1. Now, if you did a T-chart with that, and had to get back to here, you'd end up with the same identical things. We'll get more into that second semester. Okay, story problem, last problem of the video. And then you have that other sheet that's got percents, part, whole, and then it's the original percent and new without the power, because it's not per, okay? Which I think everybody gets that, so that's why I only want to make a video so long. This is long enough as it is. Okay, a pool has dimensions of 100 by 120 feet. So right there in this picture, we want to put 100, 120. Doesn't matter what goes where. Some people ask me, does it matter? No. A walkway is being built around the pool that's the same width on every side. Now measure out the dimensions. Okay, I didn't give you a lot of room here, so I'm just going to go under the words. So mark the point where the middle starts and stops, and that's 100. And from here to here is unknown, x. From here to here is unknown, but it's the same as that, so x. Now the same thing happens on the width, okay? From here to here is 120. That's x, that's x. One thing you might want to do is you see 2 x's on there, so that's 2x plus 100. And right here there's 2 x's, so that's 2x plus 120. Okay, now when we're writing a polynomial expression that represents the area of the pool and walkway, the area is the length times the width, okay? If you put L and W, well, I already have it. The length is 2x plus 100, and then the width is going to be 2x plus 120. And it's multiplication, so we need to do the rainbows. 2 to 2, 2 to 120. So 2x, 2x, and I'm multiplying by 2x and 120. Then I distribute the 100. Same two factors, 2x, 120. 1, 1, 1 and nothing, nothing and 1, and then nothing. Okay, so we know 2 times 2 is 4, and on x you add the 1s, and that's to the second then. 2 times 120 is 240, then on x you just put the 1 there. 100 times 2 is 200. Put the 1 there, that's a 2 right there, 200, that's a 2. 100 times 120, okay, that's going to be a pretty sizable number, and that's 12,000. Okay, so I have identical powers here, so I'm going to write my spaces out so I can organize them and simplify. So for x second, we just have the 4. For x, remember, that's first power, so 240 plus 200 is 440. And then in the constant space, you have 12,000. Okay, now that's the answer for A. You stop there. Now part B, you calculate the area of the walkway that has a width of 15 feet all the way around. So that means these x's that I didn't know, well, now I know that they're 15, okay? So we need to replace the x variables within the expression with an empty parentheses where we're going to place 15. So you got 4 parentheses. Remember, this one has a second power, plus 440, and then another parentheses, but that has no power because that had no power, plus your 12,000 constant, and then you insert 15 in for the variable because x equals 15, so it goes in there. So you got 4 parentheses 15 to the second, plus 440 parentheses 15, plus 12,000. Okay, and that gives me my answer, 19,500. And I'm not going to dock you for not having a label, but it's area square feet. You're finding the space inside of the shape. Okay, I hope that was made sense.